Hello, I'm Mr. Matt, and today we're going to continue with our statistics course. We're going to move on to topic 1.2, which is about variables. So in this section, we're going to be looking at a set of data, and we're going to be discussing some of the aspects of that data set. All right, so we're going to be learning a few new words today. It's mostly a vocabulary lesson. So let's begin with the first word. The first word is observational unit. Observational unit. So you can see here that an observational unit is an item or an individual from which a datum is collected. Now, it could be a person, it could be a thing, it could be a place, it could be anything. Observational units are the things that we are collecting data about and we are describing with that data. Okay, so we're describing the observational units. That's important to understand because a lot of times on the AP exam, they are going to ask you to identify the observational units in a data set. So it's important that you can look at a data set and identify where are the observational units. What are the observational units? So if we look down here, I have a set of data right here. And in this set of data that we have here, we've got several observational units. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different people. So in this example, the observational units are people. And this data over here, the stuff over here, this data is all being used to describe these observational units over here. All right, so the data describes the observational units. Got it? All right, let's move on to the next word. The next word here, the next term is variable. Variable. And a variable is just a characteristic that may change from one observational unit to another. All right, so variables are values that we measure or collect that might change from each individual. And when I say values, I don't necessarily mean that they are numerical values. They could just be a word, a category, or something like that as well. So let's look at the variables in our data set that we have here. The first variable that we have is the residence district. All right, so right here we have residence district. Okay, then we have age, we have marital status, we have height, weight, education, and postal code. And you can see that for each of these, the values may change. Now, that word may is very important. May means maybe they will change, but maybe they don't change. For example, if we look at the marital status variable, we'll see that there are several individuals with the same value of marital status, married. For example, we see here that Wang Cao is married. We see that Li Wei is married. We say that Liu Yang is married. And we see that Sun Qi is married. All right, so we have 4 married people. So they have the same value for that variable, but there are other people that have different values for that variable. There's Zhang Ming is single, all right, or Huang Kai is widowed. All right, so we can see that it might have different values for each. So that's why we call this a variable, because it could have different values for each observational unit, for each person that we're describing. Now, real quickly, I want you to notice that the variables are describing the observational units. For example, let's look at the first person here, Li Wei, and we can describe Li Wei using all of these variable values. So, what district does he live in? Dongce. What is his age? 34. What is his marital status? Married. How tall is he? 178 centimeters. What is his weight? 72 kilograms. What is his highest education level? He has a bachelor's degree. And what is his postal code? 10007. Okay, so we get all of these values for each of these variables, and the values of those variables together describe leeway. How many variables do we have here? We have 7. 1, 2, 3, 4, 5, 6, 7. Now notice that the column name here is not usually considered a variable, because that is just an identifier for our observational unit. It's not really a variable for them. Okay, let's move on. We're going to now talk about different kinds of variables. There are different kinds of variables here. So let's look at the first kind of variable that we have. We have quantitative or a numerical variable. These are two different ways of saying the same thing. So you need to know both of these words. Quantitative variable, numerical variable. They are the same thing. All right. What are they? What is a quantitative variable? Well, it's a variable that takes on numerical values for a measured or counted quantity. It usually will have some sort of unit of measure. Okay? So let's look up at our data set and let's see if we can figure out which of these variables are quantitative variables. Well, Dongteng, or resident district, the values of that variable are not numerical. So we know that this is not a quantitative variable. So resident district is not a numerical variable. Okay? Age, that does take on numerical values. 34, 29, 42. This is a quantitative variable. Good. So quantitative. Marital status? No. Height? Yes, that is a quantitative variable. Weight? Yes, that's a quantitative variable. It takes on numerical values. Education? No. What about postal code? Now, this one's a little bit difficult. It's a little bit tricky because, yes, it is numerical values, but it's important to read the rest of this. Remember, it says down here that it takes on numerical values for a measured or counted quantity. Postal codes are not measured and they are not counted. They are just a category that we put someone in. Yes, it is a number, but it is not a measured or counted number. So even though postal code has number values, numerical values, it is not a quantitative variable, all right? Not a quantitative variable. Okay, so that's quantitative variable. But unfortunately, we also are going to split quantitative variables into two different categories. There are two different kinds of quantitative variables. The first kind of quantitative variable is called a discrete quantitative variable. Discrete. And what is a discrete quantitative variable? It is a quantitative variable that can take on a countable number of values, usually whole numbers. They are counted, all right? Discrete quantitative variables are counted variables. For example, age is usually considered a discrete quantitative variable because you count how many years you've been alive. 1, 2, 3. People don't usually say, I've been alive for 3.82 years. All right? No. Well, they don't say anything because they'd be too young. But they don't say that because we usually just count age in year units. We don't count the decimal points or anything like that. So that's why age is typically considered a discrete quantitative variable. Okay. Another type of a discrete quantitative variable, another example would be something like how many pets does this person have? All right. He could have 1 pet, 2 pets, 0 pets, 5 pets. All right. It could have numbers, but it's always counted. 1, 2, 3, 4. It's usually a whole number. It's always a whole number. We're never going to say someone has 3.4 pets. That would be a little weird. Okay, so that's the idea behind discrete quantitative variables. They are counted. Next, let's look at the other kind of quantitative variable, continuous quantitative variables. Those are quantitative variables that are measured values. Typically, with continuous quantitative variables, it says here that they can take on an infinite number of values within any given interval. Okay? So, for example, between 178 centimeters and 179 centimeters, there's an infinite number of decimal values that you could have between them. So we call that a continuous quantitative variable. Now, even though we usually report our height in a whole centimeter number, like I usually will say that I'm 169 centimeters, but typically we consider height to be a continuous variable because really the measurement of our height is only restricted by how accurate our measuring device is. Okay, so if I have a very accurate height measuring device, ruler or something like that, I could measure my height and be like, it's 169.73 centimeters. All right, something like that. Okay, so that is typically considered to be a continuous quantitative variable. Same thing with weight. Weight would also be continuous. It is the accuracy is only restricted by our measuring device. Okay, so let's move on. That's the type of quantitative variables we have. Let's look at categorical variables. Now, what is a categorical variable? Or sometimes we call it a qualitative variable. So you have quantitative and qualitative. All right, or we can say they're numerical or categorical. All right, so make sure that you know those words. So what is a categorical variable? Well, it's a variable that takes on values that are just category names or group labels. Right, so if we go back up here to our data set, which of these variables are categorical variables? Well, the district, the resident district, that's a categorical variable because it's putting people into categories based on which district they live in. All right. For example, we see that Li Wei and Zhao Ling are in the same district, Dongcheng. All right. So they have the same value of that categorical variable. They are in the same category. What are some other categorical variables? Well, marital status. That would be a categorical variable. Education, the education level, that would also be a categorical variable. And postal code, even though postal code is a numerical value, it is a number, but because it is actually putting people into categories based on where they live, that is a categorical variable. All right. Now, I've got a little bit of a star next to this next word here. Please pay attention to this word. This word is very important in statistics, and it is sometimes a word that is difficult for students to really understand. But make sure that you spend a little time to think about this because it's very important, and we're going to be talking about it throughout this course. And that's the idea of what is the distribution of a variable. We are going to be talking about distributions a lot throughout this course. So it's very important that every time I say that word, distribution, that you have some understanding of what I'm talking about. Well, a distribution of a variable is just all of the different values that that variable might take and how often it takes those values in the data set. All right. So if we were to look at, for example, resident district, what are all the different values that the resident district variable can take? Well, Dongcheng, Caoyang, Haidian, Xicheng, and then Caoyang again, Dongcheng again, Changping, Shunyi, Haidian, and Xicheng again. All right, so those are all the different possible values. All right. And then we could also count how many times it takes each of those values. Well, it looks like there are 2 people that live in Dongcheng, and then there is 2 people that live in Haidian, and 2 people that live in Xicheng, and then 1 in the rest of those areas. So that would be the distribution. 2 for Dongcheng, 2 for Haidian, 2 for Xicheng, and then 1 for the others. That's the distribution of the district variable. We could do the same thing for marital status. How many people are married? 4 people are married. How many people are single? 4 people are single. And then how many people are divorced? 1. How many widowed? 1. All right, so that's the distribution of our variable for marital status. It's 4 married, 4 single, 1 widow, 1 divorce. That's the distribution. Okay, so whenever I'm talking about a distribution, I'm talking about the different values that the variable can take and how often, how many times it takes each of those values. All right, so it's very important that you understand that. All right, and then the last 2 words that we're going to talk about here are also very important. We're going to be using them throughout the year. We'll use them more later on. All right, but it's a good idea to have an understanding of what they are. So let's look at the first word, parameter. What is a parameter? It's a numerical attribute or summary of a variable of interest for a population. All right, that's a little bit of a fancy definition. The way I usually like to just define the word parameter is that it's a numerical value that describes the population, the whole population. For example, if you remember back in topic 1.1, our investigative question was, what is the average height of all the residents in Beijing? So the parameter would be the average height of all the residents in Beijing. That's describing the population. The population is all the residents in Beijing. So that number is a parameter. Now, if I just take 10 people, these 10 people as a sample of people from Beijing, and I count their height, I record their heights, and I calculate the average of these 10 people, well, then I've got a number that is describing this sample of 10 people. A number that describes a sample of people is called a statistic. All right, that's this last word here, statistic. It's a numerical attribute or summary of the variable of interest for a sample. So notice, if we are describing the population, the average height of all the residents in Beijing, all the adult residents in Beijing, that is a parameter. If I am describing the sample, the average height of these 10 people in my sample, that number is called a statistic. All right. A lot of times we're going to be using statistics to estimate parameters because we don't know what the parameter is. We can't actually collect all the data for the entire population. So we use a statistic to estimate the parameter. Okay, so that's everything we're going to learn in this section. Let's look at some practice problems. All right, let's look at some practice. Let's look at number 1 here. It says, data are collected on the 35 students in a college history course. Which of the following is not a variable for this data set? Not a variable for this data set. A, student birth month. B, political affiliation of the student. C, student age. Or D, the number of students in the data set. Okay, think about it for a moment. Well, remember, what is the definition of a variable? It is a numerical or categorical value that may change for each of the observational units. Well, student birth month, that might change. Some people might be born in June. Some people might be born in February. All right, that can change. B, political affiliation. Yes, some people might be, if we're in the USA, Republicans or Democrats or Libertarian or Independent. All right, Yes, that can change from each individual. Student age. Well, of course, that can change. Some people might be 20 years old. Some people might be 22 years old. Some people might be 18. We don't know. All right. And then the last one, D, the number of students in the data set. Well, that can't change for each. That's just describing the whole data set. That's not describing the observational units. So this is not a variable. All right. So that's gonna be our answer for this one. The answer should be D. Okay. Next, number 2. A nutritionist is conducting a study on various brands of breakfast cereal. For each brand, the researcher records the manufacturer, the number of calories per serving, the weight of a standard serving in grams, measured to the nearest hundredth of a gram, and the shelf location, bottom, middle, or top. Which of the recorded variables is best classified as quantitative continuous? Is it A, the manufacturer of the cereal brand? B, the number of calories per serving? C, the weight of a standard serving in grams? Or D, the shelf location of the cereal? All right, do you have your answer? The answer here, I believe, would be C. All right, the weight of a standard serving in grams. All right, so let's look at each of these. A, the manufacturer. That would be a categorical variable. That's not a numerical value. B, the number of calories per serving. Well, that is a numerical variable, but it isn't continuous because calories are something you count. How many calories are in it? We never say there are 300.6 calories. All right, so that would be a discrete variable. And then D, the shelf location. Well, that's obviously a categorical variable, bottom, middle, or top. So the answer here is C. Next, number 3. A city transportation department monitors a busy intersection for 1 hour. For each vehicle that passes through, they record the following information. So we have the vehicle type, the number of occupants, the speed, and the color. Which of the following correctly describes the variable number of occupants? So there could be 1, there could be 3, or there could be 2. All right. Is that a observational unit, A? Or is it B, a categorical variable? C, a quantitative discrete variable? Or D, a quantitative continuous variable? Okay, well, I think the answer here would be C. It's quantitative discrete, all right? Number of occupants is something you count using whole numbers, 1, 2, 3, 4, all right? You cannot have 2.6 passengers. It's not continuous, all right? So this is C. All right, let's look at our final one here. It says an environmental agency is studying the health of 25 different lakes in a particular region. For each lake, they record the following data: the surface area in square miles, the average depth in feet, the primary type of fish found, trout, bass, or perch, and whether the lake is open to the public, yes or no. In this study, which of the following represents the observational units? Okay, so remember, if I ask, or if they ask, what are the observational units? You need to ask yourself, what is the data in this table or in this set describing? What is it describing? Is it A, the 4 types of data being recorded by the agency? B, the 25 individual lakes included in the study? C, the primary type of fish found in each lake? Or D, the regional environmental agency conducting this study? All right, so think about it for a moment. Okay, well, I hope that this wasn't too tricky for you. This one's when asking to identify observational units is something that students often find a little bit tricky. All right. Because usually we see the variables all listed out there like this, and we're like, oh, these are the variables. But remember, the observational units are the things in the table that the variables are describing. So whatever is going down this side of the table, that stuff those are the observational units. Okay, so what are we describing here? Well, the surface area, the average depth, the type of fish, and whether the lake is open, these are all describing the lakes. These are data that describe the lakes. So the answer to this problem would be B. The observational units are the 25 individual lakes included in this study. Okay. All right, so that wraps up topic 1.2. I hope that you will join me next time for topic 1.3.